AWS Global Infrastructure, Regions, Availability Zones, and Data Centers Explained. This podcast is brought to you by Business Compass LLC. We are an Amazon Web Services advanced consulting partner. We build and migrate workloads to Amazon Cloud. Our website is businesscompassllc.com. Our phone number is 973-638-2228. Our email address is contact@businesscompassllc.us. Amazon Web Services, AWS, operates one of the largest cloud infrastructures in the world, supporting millions of customers with a range of services and features designed for high availability, fault tolerance, and efficiency. Understanding the underlying architecture is crucial for leveraging AWS to its full potential. This podcast covers the foundational elements of AWS's global infrastructure, regions, availability zones, AZs, and data centers. Understanding AWS regions, the foundation of global infrastructure. Definition and purpose of AWS regions. AWS regions are distinct geographical areas that AWS uses to house its infrastructure. Each region consists of multiple, isolated, and physically separate availability zones within a geographic area. Regions allow customers to place resources closer to their users, reducing latency and complying with regulatory requirements. Multi-ISP connectivity and global network backbone. AWS regions are connected to multiple internet service providers, ISPs, and leverage a global network backbone. This design ensures low-latency connectivity and reliable network performance, which is crucial for applications requiring real-time data processing and interaction. Regional isolation for compliance and fault tolerance. Each AWS region operates independently to enhance fault tolerance and provide compliance with local regulations. This isolation helps mitigate the risk of outages spreading across multiple regions, ensuring that customers can maintain availability and meet legal obligations. Choosing the right region for your workloads. Selecting the appropriate AWS region involves considering proximity to end users, available services, compliance requirements, and cost. AWS provides tools like the AWS Region Table to help customers make informed decisions. Availability zones, building blocks for high availability and fault tolerance. Data centers within a region, the physical infrastructure. Availability zones consist of one or more data centers equipped with redundant power, networking, and connectivity. These data centers are built to operate independently, ensuring high availability and fault tolerance. AWS distribution, ensuring redundancy and load balancing. AWS strategically distributes AWSs within each region to ensure redundancy and load balancing. Customers can architect applications to use multiple AWSs, thereby enhancing fault tolerance and reducing the risk of single points of failure. Multiple AWSs, designing for failover and resilience. By deploying applications across multiple AWSs, customers can achieve high availability and resilience. If one AWS experiences an issue, the application can fail over to another AWS with minimal disruption. AWSs as single points of failure. Mitigation strategies. Although AWSs are designed for high availability, they can still represent single points of failure if not adequately managed. Strategies such as cross-AWS replication and automated failover mechanisms help mitigate this risk. AWS data centers, powering the cloud with security and efficiency. Physical locations for data storage and processing. AWS data centers house the physical servers and storage devices that power the cloud. These facilities are strategically located to optimize performance and security. Redundancy and failover mechanisms for continuous operation. Data centers are equipped with redundant power, cooling, and networking systems. This redundancy ensures continuous operation even in the event of component failures. Custom network equipment and protocols for optimal performance. AWS employs custom-designed network equipment and protocols to enhance performance and security. These innovations help AWS maintain a high level of service and reliability. AWS Service Level Agreements, SLAs, understanding the commitments. Defining levels of support, hours, and services covered. AWS SLAs define the levels of support, hours of service, and specific services covered. These agreements assure customers of the availability and performance of AWS services. AWS Customer Agreement, changes, security, responsibilities, and termination. The AWS Customer Agreement outlines the terms of use for AWS services, including provisions for changes, security responsibilities, and termination of service. Understanding this agreement is essential for managing compliance and operational risks. Disclaimers, limitations of liability, and quality of service. AWS includes disclaimers and limitations of liability within its agreements to manage customer expectations regarding service quality and reliability. These terms are essential for understanding the boundaries of AWS's commitments. Customer experience, availability, and designing for failure. AWS's infrastructure design emphasizes customer experience and availability. Designing applications for failure involves implementing best practices to ensure data retention and minimize downtime. Designing for failure, ensuring application availability and data retention. Mitigating compute failures and prioritizing data retention. AWS provides tools and services to reduce compute failures and prioritize data retention. Techniques such as automated backups, replication, and snapshotting are critical for data protection. AWS services with built-in redundancy and failover. Many AWS services, including RDS, S3, and DynamoDB, have built-in redundancy and failover capabilities. Leveraging these services can simplify the design of highly available and resilient applications. Best practices for cloud design to minimize downtime and data loss. Adopting cloud design best practices, such as using infrastructure as code, IAC, implementing continuous monitoring, and conducting regular disaster recovery drills, helps minimize downtime and data loss. Conclusion. AWS's global infrastructure, comprising regions, availability zones, and data centers, is engineered for high availability, fault tolerance, and performance. Customers can architect robust and reliable applications that meet their operational and regulatory requirements by understanding these foundational elements. Thank you for listening to our podcast. Please share this podcast, visit our website, and follow our social media links.